We need to simplify the following expression, and whatever simplified value it get, we will use it to obtain the value of these two expressions. So let's begin. We'll start with the numerator. So here we have 1 plus sine theta plus cosine theta. Now this can be also expressed as 1, this is iota, 1 plus, so we'll convert the sine to cosine. So we'll consider cosine of pi over 2 minus theta plus iota times, so we'll convert this cosine function to the sine function by considering sine of pi over 2 minus theta. Now we know that, let me note this down here, cosine of pi over 2 minus theta. Now since we have an odd multiple of pi over 2, the cosine will become sine of theta, but pi of 2 minus theta, that's in the first quadrant where everything is positive, all the trigonometric function will have positive sine theta. Similarly for sine of pi over 2 minus theta, since we have an odd multiple of pi over 2 here, the sine pi over 2 minus theta will become cosine theta, and this is also going to be positive because we are still in the first quadrant. Now this has been done because we can combine this into a single cosine function using the half angle formula, which is given by cosine 1 plus cosine of theta equals to 2 times cosine squared theta over 2. And we can expand sine theta using the half angle formula to get 2 times sine theta over 2 multiplied to cosine theta over 2. That means we will have 2 times cosine squared, so we'll have to take the half of pi over 2 minus theta, so this is going to become pi over 4 minus theta over 2 plus iota time, so expanding the sine function gives us 2 times sine pi over 4 minus theta over 2 multiplied to cosine of pi over 4 minus theta over 2. Now what we can do, we can take 2 times cosine of pi over 4 minus theta over 2 as the common function, so this will get multiplied to cosine of pi over 4 minus theta over 2 plus iota times sine pi over 4 minus theta over 2. So let's label this as number 1. Now we can work around with the denominator as well. So in the denominator we have 1 plus sine theta minus cosine theta. So here also what we can do, this is minus iota times cosine theta. So this we can apply the same property here, and this is going to give us 2 times cosine of pi over 4 minus theta over 2 multiplied to cosine of pi over 4 minus theta over 2 minus iota times, so earlier we had plus, now we will have a negative here, so we have negative iota times sine of pi over 4 minus theta over 2. So we'll label this as number 2. Now what we'll do, we'll divide equation 1 with equation 2, so we have 1 divided by 2 such that we have 1 plus sine theta plus iota times cosine theta whole divided by 1 plus sine theta minus iota times cosine theta. So this will be equals to, so here the 2 times cosine of pi over 4 minus theta over 2, this will get factored out from both the numerator and the denominator, and this leaves us with cosine of pi over 4 minus theta over 2 plus iota times sine of pi over 4 minus theta over 2 all divided by cosine of pi over 4 minus theta over 2 minus iota times sine pi over 4 minus theta over 2. Now if we consider our denominator, so here we have a negative sign here. Now here we'll use the De Morgan's theorem, which states that, let's consider the De Morgan's theorem. So whenever we have cosine of theta minus iota times sine theta, this can be also expressed as cosine of negative theta plus iota times sine of negative theta, because we know that cosine of negative theta cosine being an even function, so cosine of negative theta will be positive, and sine being an odd function, cosine of negative theta will be negative sine theta. So this is done, so that we can rewrite it as cosine of theta plus iota times sine theta whole raised to the power of negative 1. Now using this de Moivre's theorem, we can also represent the denominator as, so we will have, so let's write it down. Then the numerator, that remains the same, where cosine of pi over 4 minus theta over 2 plus iota times sine pi over 4 minus theta over 2 whole divided by, so here we have a negative sign, but what we'll do, we'll make it positive and consider cosine of pi over 4 minus theta over 2 plus iota times sine pi over 4 minus theta over 2 all raised to the power of negative 1. Now here we can see that the numerator, the expression in the numerator and the expression in the denominator is exactly the same except for the power. That means we can combine the denominator by taking it to the numerator and combining it with the expression in the numerator. So this means we will now have 1 plus sine theta plus iota times cosine theta whole divided by 1 plus sine theta minus iota times cosine theta. So this will now become equivalent to cosine of pi over 4 minus theta over 2 plus iota times sine pi over 4 minus theta over 2 whole raised to the power of positive 2. Now what we'll do, we will raise both sides with the exponent. We go back to question here. So here we will have to raise it to the power of n here. So that means this will be raised to the power of n, and on the right hand side it will get multiplied to 2n. Now what we can do, we can finally use the de Moivre's theorem. So that means we'll have to multiply 2n to the argument of the cosine function, which is pi over 4 minus theta over 2 plus iota times sine 2 pi multiplied to pi over 4 minus theta over 2. So this becomes equals to cosine of, so here 2n times pi over 4, this is going to give us n pi over 2 minus n theta plus iota times sine, we have n, so this is 2n, to n pi divided by 2 minus n theta. So this is the simplified form of the given expression. Now that we have this particular expression, what we'll do, we will use it to obtain the value of the other two expressions. Let's do that. Here we have our theta, so that's given by 2 pi over 9, and our n value, so that's given as 18. So we'll substitute this value into this simplified expression, so that means this will now become cosine of, so we have n pi, so n is 18, 18 pi over 2 minus n times theta, which is 18 times 2 pi over 9 plus I times sine of n pi, so n will be 18 pi over 2 minus n theta, which will be 2 pi times 2 pi over 9 multiplied to 18. So this is going to give us the value cosine of 9 pi minus 4 pi plus iota times sine of 9 pi minus 4 pi. The 9 minus 4, that's 5, so we have cosine of 5 pi plus iota times sine 5 pi. The cosine of 5 pi, so this value is equals to negative 1 plus iota times sine 5 pi, that's 0. So that means this entire expression has a value of negative 1. Now let's go to the other expression. So here we have our n value, that's equals to 8, and our theta value is pi over 8. This implies that n times theta, so this will be 8 multiplied to pi over 8, which is simply equals to pi. And the value of n pi over 2, so this will be equals to n, which is 8, 8 multiplied to pi over 2, which is equals to 4 pi. That means n pi over 2 minus n theta, that this value will be equals to 4 pi minus y, which is equals to 3 pi. So therefore, this expression will then be equals to cosine of 3 pi plus iota times sine 3 pi. Cosine of 3 pi, that's -1, plus iota times sine 3 pi, which is 0. So this expression is also going to have a value of -1.